hear what Neil
And
was
recording.
saying to Guy?
Yeah.
He's like,
Okay,
I
please tell Taylor, Austin, what Neil was saying. Wouldn't she like to know?
So, dirt bikes, there's 2-stroke and then there's 4-stroke. Neil's saying he wants a 3-stroke. There's no such thing as a 3-stroke.
No, he
Isn't
wants
that
a
funny,
6-stroke.
Taylor? Isn't that so funny?
It is
Stop,
funny.
Kristen.
Yeah.
He asked you.
Austin should be. Austin, I think, has a career.
A comedian.
Nope, a fungus,
Oh,
mushroom.
I was a mushroom
Next
once.
shot.
It's more important than
I know.
Hey, at least you'd feed a family of Smurfs.
Oh no, it was this one guy just walking through the woods and then, yeah, he died after he ate me.
La 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 la
Oh, that sucks, eh?
la. Okay, exothermic, endothermic. So Taylor, to catch you up to speed, exothermic reaction is a reaction where energy is put in, and energy is the reactant. So in a chemical equation, you could actually write that energy plus the reactant yields product. Exothermic is the reaction where energy is released. So it'd be like you mix two chemicals together and you feel your substance get warm. So reactants yield products plus energy. In the endothermic one, that's where you have to take like a Bunsen burner or a hot plate and heat up the chemical to get it to react. Okay, now we're to the point where we're at the 5 types of reactions. We have combination, decomposition, single replacement, double replacement, and combustion. Okay, so that first category of reactions was a combination set of reactions. And what you're doing here is you're taking 2 chemicals and making one product. That's really all it is. 2 chemicals, 1 product. It's kind of like making a sandwich. Taking bread, taking meat, putting it together.
You say a sandwich?
Yeah, sandwich.
Sandwich.
Or sandwich. We're saying a ham sandwich.
Ham sandwich.
Ham sandwich. Okay, so 2 chemicals, 1 product. So A plus B yields AB. That's a combination reaction. So in the examples we had here, we had the magnesium ribbon where we burned and we got magnesium oxide. Mg plus O2 yields MgO. That was a combination reaction. It's also another type of reaction we'll talk about a little later. The second one, we took magnesium plus the water and got magnesium hydroxide. Then the last one, we took copper and we reacted it with the flame and we got copper oxide. Speaking of which, in those 3, while we're at it, while we're going through each one, what was so unique about the magnesium ribbon while we were burning it? What was really kind of unique about that? Huh? That one really didn't turn all sorts of different colors so much. But when you burned it, why did you have to turn your head even a little bit?
It was bright.
Yeah, that's
I
what
looked-
was so unique.
I
about it.
looked
It was
every time.
Really,
I looked right at it.
So if you, that's why it said, careful, do not look directly at it because it's very, very bright.
It says in the thing not to look at it, but I still looked at it.
I ate it.
Okay, the second one, magnesium oxide plus water gives us magnesium hydroxide. Now with that one, since we reacted the solid with water, I think that's one where we took the red litmus strip and then we placed it in the substance. What happened to the red strip? Turned blue, like your color of your shirt, or Gabby's shirt, or Luke's shirt. Or my shirt even, I guess, come to think of it. So, turning from red to blue, what's that an indication of? Anybody?
Exothermic?
No. Just was curious if from previous knowledge.
Presents on hairs.
Presence of a base. Yep. So when you go from, if you take a piece of red litmus paper, if it goes from turning red to blue, that means that your substance is basic. In fact, anything that you see that has OH in it is basic. Then the last one, copper plus oxygen gas yields copper oxide. And did anyone see anything unique in that one at all that they recall? Again, not that you had to, but was wondering. So all three of those types are combination reactions. The first one would definitely be an example of an exothermic reaction, seeing that really bright light. The third one, when it starts to burn, should be an exothermic reaction. But I don't know if anyone really got it to light on fire or not. I think mostly it seemed like people just were taking it and putting it under the flame. I don't think it really caught on fire, did it, for anyone?
What did?
Copper?
No.
Okay. I think mostly for everyone it just turned like a really glowing red. I don't recall anything specific happening there. Category B, that's a decomposition reaction. That's literally just the reverse of this. So that's where you have a chemical. So you have one chemical produces two products. So this would be AB yields A plus B. So a chemical breaks down into its components. So in that one, the first one we had there, you had baking soda, also known as sodium bicarbonate, breaks down into sodium oxide, water, and carbon dioxide. Or another one that you saw earlier this year in a video, you can take water with electricity, put an electric current to it, and you break it up into hydrogen gas and oxygen gas. That's another example of decomposition, breaking it down into its components. Now, I think it was the category B one. One group had their baking soda rise up from the bottom of their test tube. I was thinking that was Mackenzie's group. Wasn't it?
It was your guys'.
That's your
I
group?
wanted to poke it
You
with the thing.
Did you guys figure out why it rose up? No? Anyone in here, do you have an idea why theirs might have rose up? What would have forced it to come up? When you look at the products of that reaction. Products being sodium oxide, water, and carbon dioxide. Did you guys have to put a flaming splint in that one?
Yes.
What happened to the splint?
Went out.
Went out. Why do you think it went out? No oxygen. Yeah. What makes bread rise? Hmm? Yeah, the yeast. But the yeast does something to make it rise. The yeast eats the sugar in the bread. And guess what? It produces something. Hmm? No idea? Yeah, that's honestly what it produces. So it's kind of like, okay, and obviously I know a little bit gross, but all of us have all of us have digestive systems. We eat, we produce gas. Guess what? So do yeast. They eat, they produce gas in the form of CO2. And it's that CO2 gas that rises the bread and makes it so nice and light and fluffy. So that's why bread dough rises. Yeast digests that sugar, it produces gas to make the bread rise. So Kenzie, why do you suppose your product rose then?
Because it took out everything.
Because it did what?
It took everything.
Took away the what?
It took away the inside stuff.
Yeah, it's because it produces CO2. The CO2 gas made it rise. Okay? So that is why you saw that rise. CO2.
Why did everybody else's?
Huh?
Why did everybody else's?
Depends on how much they had in it and how hot they got it too. The more you have in it and the hotter you got, the more CO2 gas you're going to produce. Okay, so that category B reaction, that first one, would that have been an example of exo or endothermic? Endothermic. You had to take your Bunsen burner and heat it up the whole time. Okay? Reaction C, single replacement. Single replacement. This is where you have. Wow, that's a lot of stars.
I think they're lost.
I'll take one. Yeah, I think they are too.
That's car dealer.
As I say, there's not a car dealer in Winthrop, Iowa.
Semi.
Maybe they're looking for Country Ken's, huh? Country Ken's in the hot spot of Stanley. Okay. Category C, single replacement. This is where you have a compound plus a metal produces a new compound. We'll call it, yeah, we'll just say compound plus a metal. In other words, if I use A, B, and C, let's say we have A plus BC yields AC plus B. Okay? You actually saw this reaction at the very beginning of the unit. That was the nail lab, where you had an iron nail plus copper chloride, and that produced copper metal and iron chloride. This is what an oxidation reduction is all about. All based on the electronegativities. Copper had the greater electronegativity, it took the electrons. So you had iron originally as a metal. It ended up becoming combined with the chloride. Copper originally with the chloride became its own metal. So it's like the two ions, the two positive ions swapped places. So that's why I say a compound plus a metal yields a compound plus a metal. One is replacing the other. In our category C reactions, we had silver nitrate plus copper yields silver plus copper nitrate. In fact, if you saw that silverish fuzz that was forming on the metal, on the copper metal, that was actual silver that you saw. That's why it had that really light, glimmering look to it. You were forming actual silver. Now, would we have had to purify it a lot? Oh yeah, definitely. But you were still forming actual silver. The other one being zinc plus hydrochloric acid. You reacted zinc with hydrochloric acid, and you got zinc chloride and hydrogen gas. The hydrogen replaced the zinc. I guess hydrogen in that case would be a metal, but most of these reactions are going to be dealing with metals. Number 2 in category C would definitely be an exothermic reaction, as you guys all stated previously. The other one I'm not quite so sure on as far as what would be what there, because we really didn't have a temperature change. Okay. Although I guess you could say we did have a change in color, and you probably could make an argument for exothermic on that one. Category D, double replacement. Okay. Double replacement, you're literally having compounds swap places with one another. I'll use A, B, C, and D as letters this time to show that. It should be C, B. So originally, let's say your compound is AB, you're reacting with CD. You'll get AD and CB. Remember, you always write your positive ion before your negative. So that's why I say AD, CB. So the ions are just like literally swapping places with one another. It's kind of like going to a dance. Ah, the dance. Dance of the molecules. Where those particles are moving back and forth in a spring-like lattice with a spring attached. Now, or maybe it's prime. You guys already got your dates for prom coming up?
Yep.
Yeah? Who's your date?
Not going.
No, you're not going. You're not gonna ride your dirt bike. Oh, okay, that's his day. He's gonna ride his dirt bike to prom, right?
Oh, that's not at all what it sounds like, actually.
Sorry, what?
I have a race that day. Thank you very much.
You're wanting to make me break up into two to a tune-up. Wipeout!
As long as you don't fall,
I
you're right there.
don't get it.
Hey, watch out for that bag.
Yeah, I know. You
Actually,
just wish.
There's two of them there, actually.
Question or just stretch?
I'm just stretching.
Okay. So it's kind of like, as an example of, let's say you're at a dance, and you have, obviously you and your partner are dancing. Well, let's say they say, okay, switch your partners round and round. Well, that's what this is right here. So it's like Luke and Kristen are dancing to begin with, and then Mackenzie and Michael are dancing. Then in the middle they swap partners. So then Mackenzie,
And Christian dance.
okay.
Whoa.
Well, trying to keep with the theme here, that means what I say originally, Luke and Kristen.
Yeah.
So then it'd be Michael and Kristen, and Luke and Mackenzie.
But I don't like Michael.
And then Mackenzie and Kristen and Luke
Yeah.
and Michael.
'Cause I don't like Michael.
Now, gotta remember, we go with opposite charges here. Opposites attract.
Kristen's opposite
Wait,
from
so.
No, she's not. Anyway, keeping with the same theme. Okay, so that'd be like the idea. Okay, no, I did not mean anything by that either.
Okay.
But you get the idea. Okay, opposites swap places with one another and they form two completely new compounds. Okay, we had two examples of that, silver nitrate plus calcium chloride. We produced a whitish colored silver chloride, and then we had calcium nitrate, which stayed in the solution. And then the other one, you had washing soda, also known as sodium carbonate, plus hydrochloric acid, which produced sodium chloride, water, and carbon dioxide. So the bubbles that you saw being released were carbon dioxide gas. Okay. That was a category D. Last but not least, combustion. This is basically any chemical reaction, and some of these other ones could be qualified as that too. Basically, you take any reactant plus O2. So that means oxygen is your reactant. Anything where you have oxygen gas as a reactant, that's a combustion reaction. It literally just means you're burning something. What is burning? Reacting it with oxygen gas. Starting a fire with wood, with motor oil, with gasoline, with tires. I don't know, whatever. Name your substance. You're burning it, that's a combustion reaction. Diesel, propane, kerosene, you get the idea. Candle wicks. Isopropyl alcohol, methanol, ethanol, etc. Those are all combustion reactions because you're reacting oxygen with it to burn it. Okay? And there's really no A, B, C, D type of deal with it. That's just basically you're reacting something with oxygen gas. By the way, would a combustion reaction then be exo or endothermic? Okay, what is it then?
I'm gonna say
Just take, it's 50-50 chance.
endothermic.
Why?
Wait, okay, repeat what you said. Does it involve fire?
Yeah, it involves fire.
Okay. Well, because
You're burning something. So what do
I
you think?
did
Are you
leave
having
those cookies in the oven when I left. It was about.
Are you having no. Are you having to are you releasing energy from a reaction or are you having to put energy into a reaction the whole time? Anybody feel free to chime in. Exo or endo? Kenzie?
I'm
Huh.
asking Luke.
No. I asked Austin. He said endo. What do you say? You gotta pick one or the other. It's okay. I'll ask everyone. I'm just gonna ask everyone. So,
Wait. Let me look at my definition.
exo, reaction where energy is
I
released.
know.
Endo, reaction where energy is put in.
I'm examining.
Take a
I'm
50.
gonna say exo.
Exo, okay. Claire, what do you think? Endo?
Yeah, good
Luke.
job, Claire.
This is a fire.
Fire.
Exothermic.
Okay.
Ah, good.
Michael.
Touch was the right one.
Scott.
Exo.
But
Kylie.
endo.
Endo.
Oh, no.
Anna. Endo. Ryan.
But
Exo. Grady.
I think both.
You gotta say one. Pick a side.
Excellent.
Okay. You already said Kristen.
Exo.
Allison. Huh?
Kristen,
Endo. Rihanna.
you doing a little dance?
Okay. Gabby.
Endo.
We've got a really good 50-50 split here. That's pretty good. Okay.
which one was it?
Now, think about it this way. Let's say you got gasoline. Yes, I realize, hey, leave the camera alone.
I was trying to get it on you. Because you keep walking over there.
It doesn't matter. She needs to see more of the board, not me, okay? Anyway, think of it this way.
Save her some trouble.
Or then, please, Ryan, do me a favor. I don't want my camera to break, so whatever you do, do not get in front of it, okay?
I'm not going.
Okay. So you gotta understand. So, think about with gasoline. Does it take much to get a gasoline fire started?
No.
Nope.
No. But does it produce a lot of heat?
C.
Yep.
Yes.
Yeah.
Doesn't
So
go
from
for
that
that.
idea
It's
then,
releasing.
would that be exo or endo, you think?
Exo.
That would be exo, yes. And that's the idea.
So I was
Okay?
right?
Exothermic is a combustion combustion reactions are exo. Because of the idea that, yes, it does take a little bit of energy to get it started, but the amount of energy put in compared to the amount of energy released, they're way, obviously, unproportional. The amount of energy that's released is so much more than the amount of energy that you have to
Quite
put
okay.
into it.
Quite over there.
I was
Okay.
right.
So, now, what you can work on over the weekend is obviously you can get working on your journals. You've got the readings that you can glance through and get going with that. You do have that evaluation sheet, remember, those 4 questions. That can go as part of your reflection for your lab journal, or you could put it in as a part of your, whichever. You do need to balance the chemical reactions. I'm thinking actually in terms of the lab, of the evaluation stuff, you could probably just put that in with your findings, with your observations, that's fine too. So yeah, just go ahead and put the questions in with your observations. Because it's stuff that you were observing.
Why are there Z's on this?
So anyway, Monday we will go over a PowerPoint dealing with energy bar charts and how chemical energy we can now involve in reactions.